Okay, so the purpose of this section is to study how errors in numbers propagate through functions. So for example, if we have two numbers that have errors in them, as engineers, we are interested in estimating the error in the product of those two numbers. So suppose we have a function f of x that only depends on one variable x. And if we assume that x tilde is an approximation of x, so is an approximation of x, then how do we assess the discrepancy between these two numbers? In other words, what is delta f of x tilde if it's equal to f of x minus f x tilde? Now the problem with this statement is that we don't know what f of x is. So let me just explain this with a graph. Let's say we have a function that looks something like this. All right. Now we estimate, let's say we're at this point. Okay. And we estimate the value of the function at some other point based on our step size, and we know from our previous section that we can approximate the first derivative, and let's say we land up somewhere here. We can call this value x tilde, but the true value of the next point, if we look at the true value of the slope, is actually situated here at this point x. So there is some discrepancy here between x and x tilde, which also means there's going to be a discrepancy between f of x and our approximation f tilde. And we're interested in looking at how the product of these two values, the error, propagates through our model. But we can overcome this if we assume that x tilde is close enough to x and that the function value of x tilde is continuous and differentiable at that point. And if it's true, then we can use a Taylor series to compute the value of f of x near f of x tilde. So in other words, f of x, using our Taylor series approximation, is equal to function value of x at tilde plus the first derivative value of x at x tilde multiplied by our difference plus higher order terms. We can rearrange this to say that f of x minus f of x tilde is approximated by f prime x tilde multiplied by the difference. This in itself can be rewritten as delta f of x tilde being equal to the absolute value of the derivative at our approximate point multiplied by the difference in x. Let's explore this further in an example.